Hello guys, welcome back to a brand new video. Today we're going to be doing covalent bonding and radioactivity. Before I start the video, make sure you check our channel for more videos like these. And yeah, and make sure you subscribe as well. Don't forget to like, please subscribe. So covalent bonding and radioactivity, leaving certificate chemistry. So molecules and their size. Really important definition. What we have to know what molecules is. Molecules are groups of atoms bonded together. Really simple definition. They are extremely small, typically measured in nanometers. Nanometers is an instrument used to measure atoms bonding together. Molecules form the basis of covalent substances. So yeah, molecules and their size. Covalent bonding. Covalent bonding involves the sharing of pairs of electrons between nonmetals and atoms. Covalent bonding also helps the sharing of electrons of other atoms. Atoms achieve full outer shells, forming stable molecules. Types: single, double, triple bonds. So when each atom reacts throughout the covalent bonding, it forms a single bond, or it could, depending on the type of the atom, it could also form a double atom, and it could also form a triple bonds as well. So types, we're going to be talking about different types of covalent bonds in this video as well. So single bonds. Single bonds only have one pair of shared electrons. Example H2, base or water. Water? No, it's not water. Single bond, one pair of shared electrons. Example H2. Double bond, two pairs of shared electrons. Example O2. Triple bond, three pairs of shared electrons. Example N2. So, yeah. Hydrogen with 2 for single bonds, hydrogen with 2, and O is oxygen with 2, and N is nitrogen with 2. Pretty simple. Polar and non-polar covalent bonds. Non-polar covalent bonds, this is when electrons shared equally. So this is when electrons are shared equally, the energy and the no energy is like shared equally. So each side of the atom gets equal share of electrons. So polar is when electrons shared unequally due to the electron negativity difference. So electron negativity is when you add on atoms like molecules, so electrons are shared unequally because there's an increase in atoms given to one side and not to the other side. So example could be hydrochloric acid, HCl. So characteristics of covalent substances: low melting at boiling point, poor electricity conductivity, usually gases or liquids at room temperature, soluble in non-polar solvents. And the characteristics of covalent substances. These four are basically like why a covalent bond looks like a covalent bond, like how the structure happens, like the how the covalent bond, like how is even there, like between the pH level of the room temperature or the liquids, Dot and cross diagrams used to represent shared and unshared electrons. Dots and crosses show electrons from different atoms. Examples H2O, NH3, and CO2. Everyday polar and non-polar materials. Polar examples: water, H2O, ethanol. Non-polar examples: cooking oil and oxygen gas. An example for an exam question could be like, name everyday polar and non-polar materials. You could just, simply state water, and then for non-polar examples could be cooking oil or oxygen gas. Really simple. Affect solubility and interactions in daily life. These affect. Really important, these two. The examples. Polarity test for liquids. Use a charged plastic rod to test. Polar liquids like water bend towards the rod. Non-polar liquids show no deflection. So non-polar liquids show no traces of polar in their liquid, and polar liquids like water bend towards rods, so it shows that there's polar inside that water. Solubility of ionic and versus covalent substances. Ionic are soluble in polar solvents like water. Covalent, soluble in non-polar solvents. Example, hexane. Helps distinguish bonding types. So ionic, there's like water and soluble. Okay, yeah. Types of radiation. Alpha, A. Really important. These three, alpha, beta, and gamma, are like the three types of important type of radiation, which will be in the curriculum in the leaving cert chemistry, so it's really important. Alpha is helium nucleus, low penetration. Beta, electron, medium penetration. Gamma, electron negativity, wave, high penetration. Historical discovery of radioactivity. These two are really important to learn off. Henry Becquerel discovered radiation from uranium salts. Mary Ann Curie discovered polonium and radium. Widespread occurrence of radioactivity. Natural, radon gas, cosmic rays, rocks, artificial, nuclear reactors, medical imaging. Radioactivity is a part of our environment. Thank you. Make sure you like and subscribe and ask any questions and comment down below. And yeah, make sure you check our channel for more videos like this, and I'll see you guys next time.